In other videos, we've looked at integration by parts. In this video, I want to look at a particular example where integration by parts doesn't work as it typically does, but it does allow us to find a solution. I call this a fun example because I like this particular problem a lot. So when we talked about integration by parts, we said that we wanted to choose a u that's going to reduce and a dv that's not going to get more complex. Well, both of our functions here are candidates for the dv, but not really candidates for the u because nothing is going to reduce when we take the derivative. So this is not a typical candidate for integration by parts. However, let's go ahead and use integration by parts here and see what happens. We'll just choose one of these parts here to be our u. I'll choose u is equal to e to the x, which means that dv is going to have to equal cosine of x with respect to x. And then we can use that to figure out what du is going to be and what v is going to be. So taking the derivative of u, we get du. Taking the derivative of e to the x, we get e to the x times dx. And then integrating both sides of this equation, we get v equals a sine of x. So then using this formula here, u times v is going to be e to the x times sine of x, and the integral of v times du is going to be the integral of sine of x dx. I'm sorry, I misspoke there. The integral of sine of x times e to the x dx. So again, we don't have a simpler integral here, but we'll go ahead and use this process again and integrate by parts again with our new integral. And we'll keep with what we did in the first one, and we'll let u equal e to the x, and so then that leaves dv as the sine of x times dx. And when we take the derivative of u, we're going to get e to the x times dx again. And when we integrate dv, we get negative cosine of x dx. And so replacing this integral with what we get from this formula here, we're going to have our new u times v, which is going to be e to the x times negative cosine of x. I'm sorry, that dx shouldn't be there. Times negative cosine of x. So we get f of x equals e to the x sine of x, which we had before, plus e to the x cosine of x minus the integral from cosine of x e to the x dx. Now, notice what happened with the signs there. We had a minus, but then we're multiplying by negative cosine of x, so that's going to be a positive, and that turns into a negative there. Now, again, we don't have an integral here that we really know how to integrate. However, you may notice that this integral here is exactly what we started with. So we have the integral of cosine of x e to the x dx, and that's the integral that we're trying to evaluate here. So since that integral right there is equal to f of x, we'll just replace it with f of x. And so now if we want to figure out what f of x is equal to, we can add f of x to both sides, and we get 2 times f of x is equal to, and I just factored out the e to the x here, so that's equal to e to the x times the quantity of sine of x plus cosine of x. And to evaluate f of x now, it's just a matter of dividing by 2, and we get this. So even though we used integration by parts twice and we didn't get a simpler integral, we actually got back to the integral we started with, and we were able to use that to evaluate the integral. Now, keep in mind here that we are evaluating an indefinite integral, and so since we're evaluating an indefinite integral, we can't forget that constant of integration, so we'll add our c on, and this is going to be our answer here.